Well, hi, good morning. Thanks so much for joining me in my shop here. It's August 6th, getting a little bit of a later start in the morning, but I was in here yesterday evening working on the replacement of the socket here, and I'm at the point now where I've picked the socket. I'm using this one here, and I've drilled holes. I'm about to mount the socket in and then solder up the wires, which you can see laying around here like this. I have some photographs. I'll show you the process. This was a scary project for me, drilling holes and doing stuff like that. But I have a couple screws here to screw it in. Let's look at the slides, and I'll just tell you a couple of the things I thought of to make this go a little better than it might have. Okay, hopefully these photos will help me tell a bit of a story here. So this is the socket in question, and what I've done here is I've removed the solder. I used the solder braid to remove as much solder as possible. The benefit of this, and I didn't realize it at the time, my intention was to remove these wires off and then remove this whole thing. Once I removed the solder, I noticed these holes here, of course. I started thinking, gee, why don't I just cut that? And let's take a look here. So here I am cutting them now. So I'm not trying to remove the wire at all. I'm just cutting them off and cut them. And this one's cut off here too. I'm trying to leave the wires in the same place they were always in, so putting it back together would be easy. Cutting these terminals off made this job really easy compared to what it could have been. Once I cut the last one off, I had to deal with this locking ring here, which I just got my cutters and jammed them in there and cut it. And once it popped open, the socket dropped out and it was gone. So then I fit in the new socket and determined where some holes had to be drilled so I could screw it down in place. Where's my next photo here? Okay, maybe these are out of order. Maybe that's the last one. Maybe that's the last one. I think that's the case. I think there's one more. There's one more in here somewhere. There it is. That's me dropping in the part and orienting it exactly the same as the original, because all these wires are waiting to hook up to exactly the same spot. So I had to make sure this was oriented. Also on these tube testers, this one, and I think just about all the tube testers I have, the sockets are oriented very carefully to put, in this case, to put the key spot here vertically on it. So that's it for these photos. Okay, I've got the socket all wired up there, and I think that's in good shape. 83. An 83. An 80 is a very common tube, but 83. Good. And the rectifier tube. There we are. Okay, we're ready to test this guy. Well, this is pretty exciting. I've had trouble with this socket. I better not talk until I see it work, but I've had trouble with this socket for a long time now. It's just gotten worse and worse until it's become untenable, and it's forced me into this repair. Okay, I'm going to set this up and get back to looking for a gassy tube. Okay, I think we're ready to start. So I just put this tube in here. I was kind of disappointed to find out it's hard to put a tube into this socket. This is not the best. I never tested this with a tube. Like, I never put a tube into this socket. Come on, man. There we go. Oh boy. I wasn't expecting that. Now, are we all set here? are not. Okay, I'm going to apply the power through my dim bulbs over there just in case. What might happen? Let's pull this out after putting it in. Let's pull it out. Boy, oh boy, oh boy. We're going to turn it on and see what happens. What would be the bad thing that would happen? The dim bulb lights would come on and stay on. What else might happen? The pilot light might fail to light or be dull. I don't expect any. Here we go. I don't expect any trouble. There we are. Pilot light. Voltage supply 103 through the dim bulbs. Everything looks fine. Let's give it the full Monty here. 116. Looks good. Now let's just double check the settings. I don't think I changed them, but you know, 50 volts, which I discovered is actually more like 45. I think JR 2763 2763 the 0 23 91, and the expectation is it's between about 5,000 and 7,000. We'll put this on the 6,000 scale, so if it's a really good tube it may actually go off scale up here. Okay, and we'll stick this in. As soon as we stick this in, it's going to receive the heater voltage, so we should see some action here. Yes, we did. Hey, that went in easy. Oh my gosh, don't tell me it's not heating. I'm watching this pilot light to see if it flickers. No. Are you not heating? Yes, it is heating. Yes, it is heating. Okay. So what we're doing first is I've got two 50C5 tubes. Here's the other one. One of these two is gassy. And we're going to try to figure out which one it is by doing a test. First I'm going to test them in the usual way, which is to say we do the short test, watching the short light. No shorts. We push the test button, and the expectation is that on the 6,000 volt scale it's going to be way up here. How come the meter reverse button is pushed? How did that happen? Okay, try it again. Ooh, she's a junky tube according to this. Do you believe it? Can we believe it? Let's check the line adjust. Line adjust is here. So we're way low. How come so low? 117 on the... well, that's a little odd. 116 here, yet this thing decided it was low. Okay, try again. We're now 3,500. According to this, we should be junking this tube at 47. So it's just on the verge of being junk. That's what this tube tester is saying right now. Let's pull this out. Put this one in. In you go. Definitely heating. Okay. Looking for shorts. No shorts. Ready for the test. It's a good one. Which one do you think is the gassy one? The one that throws the pointer right over. Let's put this on the 15,000 scale. I've never had it up on the 15,000 scale, I don't think. So we'd be looking at a top number of 7,500. So it's straight up. 7,500 straight up. So this is either like a really good tube or something funny going on here. There's not many tubes that get right to the top of the rating. Usually the tubes I have some wear and tear on them already. Okay, so now we're going to perform the gas test, which I have to read up on. It involves pushing these buttons in a certain pattern, doing a few things, and then looking to see if the meter movement has moved up a little wee bit or down or nothing. And if it goes up a little bit, it's a gassy tube. Something like that. I'm going to read up on the instructions and then we're going to do it. Okay, there's the instructions right up there. So gas test, the push switch P5 and P6 are used to test an amplifier tube for gas content. So P5 and P6 right here. The micromole switch is set on 3000. Okay, we're on 3000. The push switch 5 is pressed and held down while the bias dial is turned to cause the pointer of the indicating meter to read 100 micromoles. Where's 100? Well, 100 is way on the 3000 scale. 100 is just barely off. Just barely up. Okay, 100, eh? I got this right? 3000. This is the 100. That's 500. 100 just barely up. I wanted to get right above the meter to read it properly. I'm gonna set something up here. Make this go a little better. Okay, let's try this. So you're looking closely at the meter now. Now let me just check. So you're seeing some parallax there. Let me see if I can just try to get rid of the parallax. There. That's much better. So I'm supposed to push the button and raise that up to the 100 mark using the bias control. Okay, P5, gas 1, push the... Whoa! What's that mean? What does that mean? The bias was already up. Bias down, P1. Ooh, well, this isn't working out very well. What is going wrong? Let's read it again. Push P5. That's P5 I was pushing. Held down while the bias dial is turned to cause the pointer or the indicating meter to read 100. P5 is held down, P6 is pressed. So all the way along through all the years I've been doing this kind of work, I've ignored gas problems in tubes. I've been aware of the existence of it, but I really paid little attention to it. And have I ever tested a tube for gas? So I'm really in the cold on this. Make sure I'm pushing the right button. Yes, I am. That's a good question now. What should happen? What about, is the English setting still supposed to? Doesn't matter. I think the English setting only matters when you have this. Look, the English. Shouldn't this be done with it on English? Didn't I read something in here? The push switch P5 I'm contacting 100 micromoles. That's micromoles. So it's 500. So 100 is just here. But the meter is going wild. Well, maybe the tube is no good. Maybe I'm already finding that out. Hey, let me push the test button here. Any reason why I shouldn't? The bias is way off. So we'll set the bias to where it should be, 23, and push the test button. I'm on the... Yeah, this one actually read right over, didn't it? It read higher. Like this is reading 15. It should be 7,500. I think there's something wrong with this tube. This is maybe the gassy tube, and all this stuff is because of the gas. Let's try the other tube. Let's try the other tube. Okay, this one's probably pretty hot by now, so... Ooh, that just sounds like I'm ripping things apart. Out of these clamshell. Okay, out of the corner of my eye, I saw the light dip. Let's just check this line adjust again. No, it's right on. Yeah, I gotta leave that right where it is. Gotta leave everything just as it is. Okay, we're warmed up. Looking for shorts. Watching the light here. No indication of shorts. We'll do the regular test. Okay, so test weak, and the meter is sinking also, which I think is a bad indication. And you see it sink downwards. Okay, so we have the other extreme now. The tube that really looks bad. I'll put on the 6,000 scale, make a proper reading, and it's around, around 3,000. And supposedly you replace this tube at 47, which is right off the scale there. Wow, so this is testing really bad. Great, bias down to 0, pushing F1, this goes right over. Well, that's a little disappointing. I mean, it's great I put a socket in, but as for the gas test here, this is just not happening. There must be something I am missing. Hold on, is there something we're doing just before here? Noise test, gas test, gas, micromole, push the switch, held down, bias turned, pointer, 100 micromoles. 5 held down, 6 pressed. Never even get there. And the bias is set to 0. The bias maybe is operating the other way around. Yeah, maybe the bias has to be up higher to reduce it. So let's try that. So we'll put it way up here. We'll push P5. Okay. Yeah, now we're in business. Okay, doing the gas test. So we set this to 100. That looks like 100 to me. And now we push T2. Anything happen? Nothing happening. Nothing at all. Nothing at all. So this would suggest no gas in this tube. Let's put the other one back in. The reason, in case you don't realize it, the reason I'm suspicious that one of these is gassy is because one of these came out of a recent radio that was exhibiting a self-induced positive grid voltage. Self-induced, I mean not caused by the radio circuits themselves, but caused by the tube itself. That's a strong indication of gas in the tube. At the time, somehow I just couldn't make the synapses connect and realize that's what I was dealing with. So we're going to give this guy the regular test. We're going to put this to 23. I'm going to push the regular test button. A lot of heat in here now. I have this turned up so high. Kind of strange. Let's check again. Line adjust. She's good. Okay. Regular test, 6,000 scale. Bias set to 23. Right over. Wait a minute. Yeah. Wait a minute. This is the one I think is gassy. So it's just giving a reading like it's twice as good as it should be, which is kind of suspicious. Set it to 3,000. Turn the bias up high. Press gas 1. Set the meter to 100. I'd say that's 100. Push the other button. No gas in the tube. Come on, is there a third tube? Now I thought I had 4 tubes out here, but you know what? One of them is this one. This is a 25 volt version of the 50C5 or the 25C5. I don't want to put that in there. That can't be the gassy one. Well, I don't know what to think. I'd have to get that radio out here, plug the tubes back in it, find the one that's gassy, or does this positive grid thing, and then stick it back in the tube tester. I mean, to some degree, we're testing the tube tester here. And to some degree, I'm the tube tester. I'm being tested. Well, the good news is, I've got a new socket in this tube tester. I can go back to using it regularly. Bad news is, don't know what's going on with this gas test. Good news is apparently I have two really good 50, no, one super good 50C5. Super good. Here's the old socket, by the way, which I pulled out. Amphenol, made by Amphenol in Chicago. Oh well, that's it. Maybe I should go find some interesting tube to test in here anyway, just for some more fun. Why don't we do that? Okay, I'm going to turn this off. Ooh, I'm going to burn my hand. I don't want to burn my hand. We'll pull this out of here. I'll find some interesting tube to test. Have some fun with the tube tester now. Okay, just for fun, I grabbed 3 tubes to bring here, and the first tube I grabbed, shocked me, is an 83, just the same as the tube that's in here. But unfortunately, there's something loose inside this tube. Oop! You see the thing in just rolling around in the bottom of the glass? It's like a piece of rubber. Can you see it? Oh, you know what it is? I can tell. See the back of the plate here? Can you see that it's shiny as compared to the lower part? Or this plate is dark. Right there, it's shiny. So this coating has just peeled right off here. And you know why that would probably happen? Because the tube probably overheated. Or something like that happened. Think we can test this? Why not? That piece floating around there is not going to short anything out. And it's an 83. Now here's the what looks like remnants of the getter. Doesn't look very good. Yeah, maybe this guy's gassy. Hey, that'd be funny. Okay, let's give it a test. 83. Why not? 83. So we'll find 83 on here. We'll find it that way. We'll find it this way. Ooh, there's a whole bunch of them. So we got 83. Another 83, an 83V, and another 83V. So I think what's going on here is, you know, this is basically 2 tubes in one. You can see the 2 separate sections in it. So I think they're testing one and then the other. And they've just listed them this way in my tube tester. So, okay, let's do it. So 5 volts, 583. JR, those are the heater connections. 0, 3, 0, just 0, 3, and all the rest are zeros. '83, don't get it wrong now. 0 on the bias. 70 on the English if we care to use it. This only matters if you flip this to English here. Then you get the good bad thing. P3, plate number 1, and over here is plate number 2. So plate number 1, press P3, it has an asterisk. What's the asterisk for? Looks like anytime P3 is mentioned, there's an asterisk after it. What does that mean? P3. I'm going to stop and try to find out what that means before I make a stupid mistake here. Good thing I read up on that. The asterisk means this must be set on English, and you're going to use the good and replace scale. So everything is calibrated now. So a tube that just comes to here is kind of at the end of its life. Okay, so going over this again to be sure, because I've kind of been distracted. 5 volts, very important. JR03000. 70 on the English, which is really important because we're using the English now. P3, plate 1. Okay, we're ready. So we're going to put this guy in. The fat pins are here, and this tube tester has been built so the fat pins go downwards like this. There we go. Anything happening here? No, you got to turn it on, Jim. So, okay, turn it on. so we had this. This is a little. Did you see that? I don't know if you saw that because there's a reflection on it. But this light came on fairly bright. This is very much like a dim bulb system here. So if you do put in a totally shorted tube, you're going to find it right away with this light. Because I turned it on cold, the fuse light flashed a little bit. So I see both heaters have heated. That's a good sign. Look for shorts in the tube. None. So now we're going to push P3. Now we're going to see what happens. Here we go. She's a good one. Now, could be jumping around a bit because the buttons here are a little wonky, but she tests good. So I've got an 83. The little bit of rubber that's come off the plate probably doesn't make any difference at all. We'll pull it out. Did it get foggy? Hey, did it turn foggy just now? I don't remember it being foggy like that. Am I seeing things? I don't know. I don't remember it being foggy. Okay, so the gas test can only be applied on amplifier tubes, not on those. So here's another weird one. So what to make about this? It seems to be good. I better put this away because someday it may find itself inside this tester. Now here's a really weird one here. General radio type 631P1. What is this tube all about? I don't think we can test this in here. First of all, it just has a number 631, and I don't think I can find 631 on here. Not that way. 486. That's an interesting number. But yeah, 486. I guess this tube was developed to go into modern computers, but they never used the 486 tube. Of course, I'm just kidding. Don't take me seriously. Apparently, when I kid around, often people don't realize I'm kidding around. So this is a Rogers tube here. What tube is it? Well, testing a Rogers tube might be tricky. You may have to look at a list that tells you what the non-Rogers, the standard tube name is, because the Rogers use their own tube names. I don't see, this isn't going anywhere. I don't see any identifier on it. Bah! That's too bad. That coating is on the inside of the tube, I'm pretty sure. Well, we can't test it if I don't know what it is, and then it's just not coming out. Sometimes right on the top. No. Let me shake this by the microphone here. Some loose stuff in there, but it's probably down in the socket where it's... Well, I gotta find another tube here. This is not going well so far. I want some reassurance that the tube tester is testing tubes normally. I'm pretty sure it is, but I'm just looking for some proof. Hey, I got tubes sitting right here. Here's one. Here's one. This one's interesting. 50C5. Now look at this thing. See all that black junk on it? That's inside the tube. Now what exactly that is, I don't know, but I think it's pretty clear it comes late in the life of a tube. Should we test this as a 50C5? Trust what somebody wrote? Yes, we should trust what somebody wrote. Okay, I'll set this up for a 50C5. We'll try another one, which looks bad. Okay, just realized I only tested half of the 83. I have to put it back in and test it. But I got this set up now for a 50C5. JR 27630. 27630. And we're set for 50 volts. Let's put it in the nice new socket. There we go. Okay, I'm looking to see if it's heating. Yes, it is. Okay, just give it another moment. tubes that have a cathode take a little longer to heat up because the heater has to heat the cathode. It just takes a few seconds longer. Whereas if a tube is if it uses the heater as the cathode, she's ready to go almost immediately. Let's just check the line again. Good. Okay, looking for shorts. Five, 4, 3. Can you see there's a little glow there? I probably can't see it on the... Now you can see it. Right there. So, a short in this tube. Now, I've seen in the past kind of solid shorts. I really like this light up. So I think this is a high impedance short. Now that's kind of interesting because I can put this in another tube tester and measure the resistance of the short. I can't with this one, it's just got a light. Once you see a short, you shouldn't really test the tube. Is this like a partial short? No, let's not test the tube. I'm going to continue this. I don't think any other... Definitely showing up here. Okay, we're going to revert to another tube tester. One which doesn't use the... way down here. One which doesn't use the... doesn't use a light. Doesn't use a light. Here we are. Okay, so I'll get this guy. Oh, maybe it already is set up. Because 50C5 is sitting right here. Let's see. 47. Yep. 4. Yep. 12H. Yep. 1576G. 1576G. 4300. 4300. So it's all set up. It's all set up. Let's turn it on. Now, oh wow! The glass is kind of hot, but the pins are really hot on that. What we want to do here is maybe bring you down from the sky a little bit. Now, you're not probably going to be able to see the meter. You're looking at the meter for the other tube tester. So I have to tell you what happens here. Okay, don't touch the pins. Put it in. She's in. This also has a line check. Line check should be straight up. So this one's a little high. It's a little back. Okay, give it a few minutes. Now, I'm going to be going through the short test. And maybe you know what? Maybe just cross your fingers. I don't drop this camera on the floor as I do this. No, that's not going to work. It's going to be upside down and backwards. So what I will do, I just hold this like this. Even that's a little too bright. Okay, we're just letting the tube warm up. So we're going to cut off the big light. Bring in the lighter light. Now you can see it in the regular, you can see the meter sort of in the regular camera. So we just ignore this thing here. If I need to, I'll use the other camera. So here we go. Now there's 5 test positions. Each one is a combination of plate, cathode, grid, some combination. I don't know what the combinations are without looking in the manual. Here we go. Watching the meter now. Nothing showing up. There's no indication of anything here. In this tester then, I would be encouraged to carry on the test because it doesn't show any sign of leakage at all. Is this correct? This is the voltage. Let's just check. DC5, yes. Okay, test it. So it's come up into in this tester, 50C5 should be 1220. So 1220 is back here, and the pointer's all the way up to here. So this tube tests perfectly good in this tester. I really hoped the meter would come up a bit and I get a chance to read one of these things. Didn't work out. Back to the other test. Oh, put the tube down, it's hot. My little leather glove isn't the best protection here. Okay, we're going to put it back in and I'm going to give it a test. You know, I'm going to push the test button on this one. I'm thinking, is some high impedance thing going on? Or did I mess up when I put this socket in? Okay, so she's heating up fine. Let's see if I get this back on its... Wang. You know what? I'm just going to let it go like this. Further over, because it's got parallax. I'm trying to get rid of the parallax on there. Why is this not right on 0? Let me look with my own eyes here. Oh, it does seem to be a little up. A little up. I'm on the English setting. Do anything? Reverse it? I think it's just the 0 has gone off. It's probably been off the whole time, and I'm not usually concerned about so much accuracy, so we're gonna just adjust the 0 here. I didn't do anything. It looks like it went back. Oh, it's the shadow I'm looking at. Not the pointer, it's the shadow. Okay, how many more things can I do wrong? Now, tube is looking nice and hot. Short test. Watching the light. See, it's on? It's on. It's pretty clear. It's definitely on. No doubt about it. I don't want to test this tube in here. I don't want to test the tube because I'm a little worried here. What would be a bad thing that would happen? Burn the meter out. I just had a tube tester on my bench that turned out I had a burned out meter, and it's really very disappointing. I don't want to risk it with this one. So we are not going to push the test button on this. I'm chickening out. Well, who's next? Okay, I do have to go find a tube. I find just a regular. Why did I find a regular? What's a regular tube anyway? Okay, here's some of my untested tubes recently acquired. And these are pretty old. All these are pretty old. Look at this great big one right here. Is that another 83? Tell me it is. It's a 5Z3. Wow, these are great tubes. So I have not tested any of these. This is a pretty old one here. What's this? This is a 45. Wow, let's give a 45 a test. That's worth some money. Let's try testing this 45. So this tube would be mid to late 30s, I think. We'll put it up here. A 45. Okay, let's turn this down before we get into big trouble. Always turn down the filament voltage when you're done. So I say. Okay, 45. So we find 45 on here. Hey, pretty close to 50. There's a 45 there. So the voltage is 2.5 volts. I just happen to turn it right to the right spot. 2.5 volts. JR. 32 and then zeros. 3, 2, and then zeros. Oh, that's not part of the test. Zeros. 61 for the bias setting. 61 and 72 for the English if we care to use it. P4 to test 11. 165, so about 1200. So I'm on the 3000 volt, 3000 scale, so 1200. So it's up around this area here, which would be the lowest decent reading. It's not even a decent reading at that point. Double checking the tube. 45. Fat pins here, fat pins to the front. 45, 2.5. I don't want to blow this tube. Are you going to work? Ooh, it's heating up all right. So this is probably a directly heated. There's no cathode in this tube. Well, that's good. That's a good start right there. Okay, now we look for shorts. Here we go. Watching the light here. Watching the light. Flashing is fine. Oh, there it goes again. Same setting. Something funny going on with my tester. So here we are in position 3, nothing. On the way to 4, there's a short. To get to 4, there's nothing. So what's happening here is this is a crummy switch under here. It's just one of those sliding things that's bumping into contacts. It's really a lousy switch. So maybe I got freaked out on that last tube also, because I can get it on 3 here. Okay, so I think the bottom line is no shorts. Line test, just to be sure we're not doing something crazy here. Line test. Then we push P4. Yeah, okay. Hang on here. Stay in there, would you? I got this on such a funny angle here. Well, is that good enough? Good enough. Good enough. Good enough for what we're doing. There we go. As they say, good enough for government work. Now, press P4, 1200. Okay, so we're not getting up to 1200. Now, notice it's still going up. Can you see that? It's still going up. The tube is still heating up. So what we're going to do is we're going to vary the bias slightly and see how critical that is in the measurement of this tube. You can see it's not critical at all. So we have the bias a little off. It's not going to make the tube seem like a dud. And that's the only one that we can do that with. And where is it supposed to be? 45? It's supposed to be 73. Why have I got it on 60? 73. Hit the button. So we're pretty close here. That's 1,000. You know, 1,200's up here. So I would sell the guy a new tube at this point. If it were 1940 whatever, I'd say, oh, you need a new tube. Put this on English and say, look for yourself. See, replace. So sell the tube, make some money, really good. But in the year 2000 and where are we? 2024. That tube is not bad. Okay, so I'm going to take it out. Out it comes. I think the tube tester is working fine. I mean, this tube didn't go in the new socket, but that doesn't matter. Wonderful. Really wonderful. Here's another great big tube here. Is this an 83? This is another 5Z3. Wow. Oh, 6B4. 6B4. Look at these tubes. They're fantastic. Old tubes, you know. There's a million 1950s tubes kicking around. Millions, I'm sure. Here and there and everywhere. But when you get back to the 30s and back in this area, they're getting pretty scarce. So I'm happy to have them. Well, I'm going to quit for today. Thanks a lot for watching. I think this guy's going back into regular service. Don't know about the gas test. Got to look for another chance to find a tube that I suspect is gassy and then run the tube in here and see if the gas test jives. So anyway, well, thanks a lot for watching. And what's going to be in here next? What's next on the hit parade? You know what, I might bring in a really old radio that I don't think I can make work at all, but we'll have some fun with it. Why don't we try that? A famous radio from the late 1920s. Okay, see ya.